Hello again from TAMIU Advancing Research and Curriculum. The following video contains selected recordings from the live in-person professional development workshop Dtale Cloud-Based Data Analysis Tool, which was hosted on November 3rd, 2021 by ARC data scientist Roberto Torres Sainz. In this workshop, Roberto explains how to use Dtale, which is an add-on to the Python coding program, to run data analysis from any web-enabled computer. Portions of this workshop have been edited or enhanced for ease of watchability, and timestamps have been added so that viewers can watch sections at their leisure. To learn more about TAMIU ARC's professional development workshops, contact us using our information at the end of the video or in the description. And check out the links in the description of this video if you would like to follow along with this workshop recording in order to try Dtale for yourself. And for more statistical help, contact Roberto himself using the information at the end of this video. Stay safe, stay smart, and visit ARC.
My name is Roberto Torres. I'm the data scientist for the ARC program here at TAMIU. Today I'm going to talk about the cloud-based data analysis using Dtale, which is a toolbox available for Python for free. I'm going to do an introduction for all the topics, and then we're going to get into the practice. So for exploratory data analysis, the purpose of it is to understand a data set that we have. It can be at any format. The point is to discover things within the data set. It serves to summarize results, visualize those summaries. It can also help in preparing your data set if you're interested in doing machine learning, deep learning, so that it's in a clean format, perfect for the computer to start finding patterns, but that's for another time. And then it can also define a problem statement or the definition in the database. For today, we're going to be mainly using Python language. Usually this is a Spider IDE, Anaconda, because Anaconda has a lot of data science libraries, and in there it's a Spider. And it's super nice, Anaconda. That's the one mainly scientists are using nowadays. This is how a developer usually sees the IDE for coding. This is the one I prefer to use since I have this part here, which is the variable explorer. I can see which types of variables I have, and I can open them as I'm running the code. Python is free. For anyone who's wondering how to install, I can send instructions via email on how to install it for free. You don't need administrative privileges or anything. I have a step-by-step process for this. And then we have Pandas. It's a library made for data science. The point of this is creating a data frame, kind of like an Excel file where you have your columns with headers and then your rows, which each of those has a meaning. Pandas works for Python for manipulating data in a table format. And usually when you hear Pandas, it's mainly data frames is the word that you're going to hear. In R, I don't know if any of you have used it, but it's a data frame, right? Very similar to R. And you use Pandas as the tool mainly for importing data to your environment, exporting, transforming. Pandas does all that. That's why it's the main one used for any project. And then we have Dtale, which is fairly new. I think it's like 2 or 3 years old. I discovered this one when I was in a hurry to do some exploratory analysis, and I was trying to find ways so that I can run charts easy without doing a lot of the coding. And I researched a lot on Dtale, and Dtale works with Pandas data frames. You load the data frame from an Excel file you have into Pandas, and then you use Dtale to open the data frame and start doing the analysis. So today it's mainly focused on Dtale. Now, to make everything easier, Google Colab, it's a service Google is offering for free where they let you have a Python environment where you can code in the cloud without actually installing Anaconda or anything in your computer. The advantages, like you can pretty much run it from your phone if you want, or any computer that has a web browser, you're done. Pretty much that's everything you need. You get access to free graphic processing units for doing deep learning. That's another topic. You can share with peers and you can work together similar like with the Google Docs where everyone is editing at the same time and you can see the names in there. Here is very similar. You can code and then add nodes so that everyone can start participating in the project. So for this workshop, I created a fake university called Code Test. If you can access this URL in the computer so that you can get access to the files that we're going to need, you'll have to use a Google account. So when you open it, you should see something similar to these that I have on the screen, which is Dtale. This is the Colab file. This is the PowerPoint presentation I'm presenting today so that you can access everything that we're talking today. And then we have the student data sample test. This data is completely made up. I created student data simulation. I created 3 colleges, which is arts and sciences, business administration, and medicine. And 3 majors for each of the colleges. This is what it looks like. This is the setup. So to making this project, this workshop interesting, I simulated the student performance based on the colleges. I applied weights to what's the GPA and all that, simulated. So all of these data, just to make sure it's very clear, is completely made up. In a way, you can just rerun. You see how all the values change? It's because it's generating a sample, right? Just every single time is going to be a new data set. It never exists more than once. Now that we have that, on this university, we only offer spring and summer. And for this case, we're identifying when the term ends in 1 and 0, it's going to be fall. And when it finishes in 2 and 0, it's going to be spring. Some people are familiar with this format. I am familiar with this format. I like it. The reason why I use fall and spring is because it's easier to count how many semesters and assign a year. Here we're going to explore if there is any effect on the students' first GPA when they start into the program, how many courses they have into if they pass or fail the program. Passing meaning graduating, failing either they got suspended or complete dropout from the program. I made it kind of a fair simulation, so it's kind of what you will look like in a university. You might have a few zeros in here that people who completely failed the program. And for the 99999 that I have here, that's a default that I selected because I don't know if this happened before to some people. In Excel, if you have a text with numbers and then you change it to be only a number, well, sometimes it recognizes as a text cell, which you can do math or anything. So if you leave it empty, like I have it here, it's going to detect it like not a number, which is not ideal. So yes, so the first is the college, the major, the first term first is the first semester they started. The GPA first is the first GPA they got in that semester. Courses first is how many courses were they taking in the first semester that they started. So it follows, right? It's easy to read. And then pass fail is basically this column, which is graduated or not. The terms count is how many terms pass between the term last and the term first. When you subtract, I add +1 to tell me how many terms have passed, and then terms count to graduate. I'm going to show an example here. This student here, this fake student, started in 2019-20. The last time he was enrolled was in 2021-10. But he graduated. It's in here that he passed. But the term that he actually graduated from the university was in 2022-20. So what happened is, like, for the student to complete the program, it took them 6 terms, 6 semesters, which is 3 years, right? 2 terms per year. But they took a break, either because they wanted the family to be into the graduation. They didn't apply the graduation for that term. They graduated the next term. And you can see it here. So this is how many courses they were enrolled to complete and how many from when they started, when they actually got the degree. Sometimes this happens when they are in a thesis one, where they don't have to continue being enrolled. That's, I guess, a complete explanation of what all this data looks like. Are you all like in this URL? Everyone access? Okay. So let's go ahead and double click the Dtale callback file. Oh, sorry, I run it first, but you'll see here play button, right? Like you can click that one. What this means is it's going to run whatever code you have within this space. Let me clear it so that it looks the same. This is going to install the Dtale into the cloud computer. You can see here how much RAM you have and how much disk space you have. So basically you are in a remote computer in Google servers. When you click play, it's going to run whatever Python code you have in here. For this we use pip, which is standard in Python to download libraries over the internet. It's going to install Dtale. We're importing pandas that we discussed before, and then we're going to name it pd for pandas. We're going to import Dtale, which now install. Just to clarify, pandas is already installed by default in Google servers, so we just have to import it into our workshop. So yeah, once this run, you'll see, for me it's already satisfied. It's going to mark check mark, a green check mark here saying it completed running. Now, on this code, if you click run, it's going to create an empty data frame, and you can open a Dtale instance. You see this URL in blue? If you click that link, it's going to show you this screen, and it's empty, right? But this is Dtale. If you hover the mouse on the left corner, it's going to pop the Dtale logo. You can click that one, you can load data or export anything. Let's go back to the Google Drive part where we have these files. Double click that file, the student sample. In the file, you can download the file as an Excel file. Once it's downloaded, if you're in a Google Chrome, you just can click this arrow. It's going to show in folder. It's in the user, my name, and the downloads folder. Going back to the browser, into the Dtale part, we can hover the mouse again here and load the data. When we click that one in there, we have this screen, and it's as easy as just having the folder open. You just grab and drop where it says dropping here for loading the file. It shows you two things, the setups and the data. We don't really need the setup. I just did it so that we simulate the students' performance in the fake university, but we can load data only. And there we go. We have our instance in Dtale with our data for the students in here. Now, here's where the fun part starts. And for these, I'm going to be explaining everything that I do in the PowerPoint. If you open the PowerPoint, please, if you have a recent phone, you can just open the camera and point to the screen. It's going to show you a survey for you to answer, which is these 3 questions. And we're going to be answering those as we are working on the project. When everyone is like done, is everyone good? Okay, so going back to one of the most powerful tools here is going to be, if you hover the mouse, we have this visualize tab. You can click that, and then we have charts. So we click charts, and it's going to open this dashboard where we are going to now talk in terms of the header names that we had in the Excel that I show about the first term, the GPA first, all that. So our x-axis, it's always going to be the things that are going to be on the bottom of a table. So let's select a bar chart. Everyone is very familiar with that one. And for the x-axis, let's select the college. So you see, if you notice, all that is in here in here are all the headers in the Excel file that we loaded, plus the index, which is that's I'll explain that later. So let's click college, and for our y-axis, let's say about the first GPA. So the GPA and the first GPA first. So this doesn't make much sense right now, because right now it's not doing anything other than counting how many students were in business administration, in medicine, and in arts and science. And that's because we have no aggregation. If we click this tab in here, we can measure the mean, which is the same as the average. And now it's going to tell me the average GPA first. So this aggregation is getting the average of your y-axis. Makes sense so far? So it seems like business administration on the first term GPA has the highest average GPA for new coming students compared to the other colleges, which is not really high. Everyone's not doing very well in the first term. But we can also compare with GPA last to see how they perform. And this tells us a few different things. In the blue, we have the first term GPA, and orange is the last. Pretty much, they are the same except for business administration. They start good, but they finish with a lower GPA on average, right? You know, average are not absolute. There's so many things that describe your data. But you see how this is useful, right? You can select the college, measure the GPA. We can switch on the Y, remove them, and measure the average time to graduate by college. So which header do you think we are going to select to see how long it took on average each college to graduate, all the students? Yeah, the terms counts graduate. We had it before. We show it where, let me open the original file. This one here is going to measure the average. And I have the blanks in here. So usually an average of blanks is going to ignore the blanks so that the average is a true average. It's just going to count the students who actually finish. And the average time to graduate for arts and science is 5.59 terms, which is between 5 and 6, right? For business is slightly lower. So if you are expected to get into a program to graduate faster, maybe businesses, this is counterintuitive, but medicine, it's faster, which is not true in the real life. But remember, this is a fake university. We can get away with that. And then we can add a second measurement. What if we want to compare how long it took them to complete the program and then to graduate on average? So we can add the other one, the terms count. This is weird. Students are finishing the program on average in 3, but they are graduating in 5. This is one of the issues that happens with data. That's why the data cleaning part, which is the previous session I had, is important. The problem here is that Dtale is counting the average of all the counts, while the average of the time to graduate, it has holes on it. So the average is not going to be correct because this is not comparing apples with apples. They are similar, but not the same thing. So this is not a fair comparison. For this, we'll have to do some fixing to the data, which we can discuss at the end. So coming back to the survey that you open on the phone or in the computer, it's going to pop up these questions. I want you to try it. Try the first question, run it into the detail on how you will go and create a bar chart to get that information, and then answer the question. So, bar. Okay, I guess something I'm teaching you today is how important it is to prepare the data prior to running an analysis. There we go. That looks more like it. So this one here is not true. So this is the people who fail, basically. So we ignore that one for now. That's just a quick fix to demonstrate. But we have the GPA when they last graduated now, and we can add the GPA when they started to. And then I think another function you can do here is that you can group it by major. For example, I don't know if you notice this group. It says you can click major, and if you notice what's happening is that, oh, it's individually presenting it by major. You can see it here. I can help with that. Oh yeah, that's actually, yeah. So let's see college of education. I mean college. It's still weird, right? So we have the colors here. Blue is for arts and sciences, orange is business administration, and green is medicine. And you can see them in here. In a real university, they'll make more sense because you'll find patterns like how what's happening on each college. But if you don't like it like this, because it looks ugly, you can chart per group in here. And now you have College of Arts and Science here, and you have the terms and how it's performing. So you see how fast you can do analysis. Someone asks you like, hey, can you give me by program, by this on different graph? I have a presentation in 1 hour. Like, yeah, sure. Let me just open this. So this is the power that I found with Dtale. Obviously, all these you can do in Excel, but it takes longer. The difference is that this Dtale requires for you to prepare the data prior to not have the problems that I had today because of the last minute changes I did. But that's the power of this. Another thing is you can analyze by column. Every of these columns, when you click it, you can run some analysis like the term counts graduate. Let's do a variance report. And it's going to, let me run the one that I like. Missing analysis. I don't know if you heard that one before, but visually you can see, oh wait, is my data complete, like no gaps, or are there any patterns in the gaps? When you're trying to search for data about discrimination, you might see that people not putting information when dealing with some type of people. You can do a heat map, bar that shows you how many things you're missing. But yeah, you can do a lot of analysis from here. You can even do cleaning in here, data cleaning. You can do correlations. If you're doing analysis for creating a prediction model, you can do correlations. And it's going to show you the correlation table. I don't know if you've seen before. So you have, for example, here, the amount of the terms count. There it is. Well, it is kind of correlated to the last term, but with real data, this looks way better. But this correlation matrix, you can select which ones you want. It makes your life way easier if what you're trying to do. Something that happens to me too often, or it happened to me too often, is I was running all these analyses, and once I run the program and I'm doing machine learning to predict a student outcome, I realized something is fishy, something doesn't make sense. And I figured that, oh, the students in here are something. By doing this analysis prior to that, I can find patterns like why are we having some students are thesis and some are not, but then some others are some weird numbers. Or when you have a range of numbers, like this column is limited to numbers from 0 to 4, which is the GPA, and suddenly you have 5s and 6. That's the point of doing the exploratory data analysis. You can use it for data cleaning, finding patterns, finding errors. I invite you to explore, select, like click visualize, use the predictive power score, describe the description one. It's nice. It gives you a summary of each of the individual columns, how many are missing, the most frequent that appears is PA. So this most frequent is useful when you're doing surveys. You want to see what's the most frequent word the students is having on the response, how frequent it is. GPA. It gives you the box plot for the GPA last. It's 2 point something. Oh, I have to say something before, because the second question is going to be tricky. Remember when I said that the Excel can interpret the column as a text or as a number? So this is the thing in data science or statistics where it is important to define if a number is a number or is a string or is a category, right? In this case, the terms are not numbers, they are categories. So if we go back to the detail, the part where we have the data, we can change these terms from numbers to define it as category. You just click the top, term first, and click type conversion. And here you see how it's convert to category. And that's it. You can just apply. You don't see any changes in here, but it's actually doing something. If you encounter a problem before you notice what is happening here, you can do type conversion for the last one too. It's category and apply. And finally, for the term graduation, we assign it a category. You'll see detail pandas easily assigned like this is a string, but depending on how you want to present your results, your data, you have to define you want it as a string, as a category, or as a what. So now that that is fixed, I'm not sure if we have to restart it or we can just yeah, I think we have to close and click visualize again to open the charts. Oh, by the way, here, like when you click the play button in here you can find the instances that you have open. I'm going to delete mine because I made a mistake on my part while converting. I converted the wrong column. So I'm just going to reload my data. Well, this might be an opportunity to show you another advantage of the cloud. When you click these three lines on the Colab, you have this folder here. And here you can upload files to the virtual environment. So you can go ahead and click and upload the file from there. The sample, click open. And this is just a reminder that everything you put in there is going to be completely deleted at the end of the day, because this is just run. But you see how now your file is here in the computer. So the other code that I have is how to just run it from here. Okay, so now if you click that one in there, now this is another way here using pandas to load the Excel file that we have here. It has many reasons why you want that. You can even load your Google Drive to access the files that you have stored in Google Drive. Yeah, like I just shut down and restarted. Like that's pretty much what they teach you to fix computers, right? Just first thing is to reset, and usually that fixes. Sure. So I will not put sensitive data when dealing with the cloud, but the thing is, this is Google Colab, right? This is a public service, but there is this thing named Jupyter Notebook, which basically Google is a Jupyter, it's a notebook. You see how I added text and the code? When you have a business or your own house or teams, whatever, you can create your own server, which is going to act as Google Colab, and everyone can be part of that server, similar to how we here have the TAMIU, EDU. So in that way, it's very secure because everything is in here. One of the things that I will wish maybe in the future we can do for research is open a notebook server so that we can work for research. Because you can see the potential for this, right? Like you can code on the same project and work on it and present, and yeah, I like it very much. And I personally don't use Google Colab for analysis because of the insecurity for the server, but I do use Python personally for doing these analysis. So it's kind of secure. This is saved in your Google Drive. So unless you lose your password, yeah, but everything is supposed to be encrypted. So yes, so this is kind of an introduction on everything. It was a combination of the cloud, the Python environment, and using Dtale. For any other questions, you can reach out to me. I have my info in the PowerPoint. And if you're working on research, you're having problems with how to prepare data, I can help you with that. I am mainly focused on helping graduate students quality of life by having answers for how to deal with data. Oh, and if you're interested in knowing how to do a simulation, something like this in Excel, I love doing this stuff. You can reach out to me.